AnyLogic, this is great, great thing. AnyLogic provides a thing called environment.applyNetwork, which allows you to recalculate a network in a way that, for example, can include a new node, or have a node deleted. So we could, for example, add a node into a network and then say apply network, and it will wire that person up. Okay. I will show an example of that just before our break here, and then we'll finish up. So there's some methods for connecting people and deleting connections, and these are the two methods here. So per Sergey's question, if you have an agent and you have a reference to it called agent A dot connect to, and agent B, it'll connect to agent B, and you could just say disconnect from. It's as simple as that for connecting people.
Since it's bidirectional, can I initiate it from the other end?
Yes.
So
Yeah. So it doesn't matter if it's agent. The outcome of it is going to be the same, regardless it's agent A dot connect to agent B or agent B dot connect to agent A.
Remember you mentioned that the line has this polarity, and plus would be in the center of the oval.
Oh yeah, yeah.
So it doesn't make any difference when you delete it.
Yeah. So logically, the network connections are bidirectional. In terms of the graphical depictions of them, that's where that plus sign came in. That was not about the logical connection, but instead about the geometric representation. So it's a separate issue. Okay. So great question. And then there's various methods for dealing with these. With use get connections number, you can ask, is agent A connected to agent B? You can ask, give me your nth connected agent, where n starts at 0. And you can say, hey, give me all your connections. Give me all the agents doing you're connected. And that gives a list you can kind of iterate over in a way that we'll see. So just to let you see this, I'm going to, this will be sort of a sneak peek at something next time. What I'm going to take is this model here, and I'm going to go to this oval, okay? And under dynamic, I'm going to do something that you haven't seen before, at least here. I'm going to go down to on click, okay? This is what's called a handler. It's an event handler. But the events we've been talking about so far are kind of events in the model, transitions and message sending and an explicit event firing and so on. Here, this is a UI event. This is a person doing something with respect to the model's graphical interface, particularly clicking a node, okay? So when this says on click, I'm going to do this dot get main. What does get main do? That gets the, a reference to the object representing the main class, right? An instance of the main class. And then I'm going to do add underbar population, okay? Does anyone remember what that does? Adds a new person in the population, okay? So what I'm saying is, hey, when I click this node, do something, and specifically add someone into the population, okay? So that's in the on-click of the oval associated with the person, right? Okay, so now I'm going to run this with a tiny population, say. Sorry? Oh, thank you. Semicolon, okay. What's a semicolon? Fine. Have your semicolon. Yeah, well, yeah. Sometimes it puts it in, sometimes it doesn't. So if I were to go here, hey, so where's my person? Well, how many people are there? I'm going to click on this. Clicking, in case you can't tell. And look at that, there's 36 people there. Where are those people? Well, it hasn't drawn them, okay? So what do I have to do? Let's go back to that. So you add person, but that's not enough to show it visually. It's enough to do it logically to add them to the population, but we actually want to do something more than that. We want to visually show it, and we want to wire them into the network, okay? Okay, so what we want to do is this dot get main again, because again, we're going to be working with the environment. The name of the environment dot apply network, okay? So we're telling the environment, hey, go update your network to take into account these new people. Note, we could do that if the people are moving around too. Maybe we have a distance-based network and people are moving and we wanted to sort of recalculate the new network based on their movement, okay? You got that? Okay, so now we're gonna run this. And do this, and here it's doing a network recalculation. Now you notice it's actually completely sort of rejigging the network here. This is a scale-free network, and the more we have, look at those nodes grow. The king nodes are bursting before us. So it's a bit of fun to start the weekend. Yeah. So, but I mean, the implication of this. I mean, this is a bit of eye candy here, but the implication is pretty significant here because we've crossed the line from dealing just with built-in events to dealing with user interface interaction. We also have seen, though, that you can quite readily get it to sort of update a network to take into account new information, and in fact, to add new people into a population, right? And you'll notice, incidentally, when I did that, that thing of sort of add population, I was actually prompted here. There were actually two add populations. There was another one where I could specify the income and the sex. So I could actually add people in with sort of arbitrary characteristics that I specify. I didn't choose to do that just for speed. I just used the defaults. So these are the defaults for people, okay? But that illustrates response to user interfaces. It illustrates the ability to sort of add people to a population, and indeed to get it to recalculate a network.
If you were to wire the existing network, you have to do because if you model some
right.
environment,
right.
you would probably never want to recalculate all the connections to.
Yeah, well, but let's think about this. So the way in which it generates a scale-free network actually involves a series of steps where it's kind of parceling out these new links, and it gives more of a chance to those who already have links. And so if you add someone in de novo at the end, it's kind of hard to figure out how many links do they deserve, so to speak, right? And I think it's because of that. Let's yeah.
Well, I was just thinking, like, you could have a developmental period, right, where a new person is a baby and they have a certain chance of getting
right.
a new link every year,
right.
But then future links are proportional to previous links. So, you know what I mean? But it's the
yeah.
same sort of model over time for individuals.
Right.
Something like that.
That's interesting.
That is
But
interesting.
it seems like it is something that you have to develop, build into your model.
That could be an addition for necessary
Yeah.
like baby model.
That's interesting. Let's go back though to environment because I want to illustrate a principle here. Let's go back to environment, and on environment, let us instead of a scale-free network, let's do a distance-based network. Okay. So we're switching it to a distance-based from a scale-free. We had those hubs growing before, but now we're going to have a different situation, right? So now let's run the same model, right? And hey, huh? Oh,
Distance is 100. Maybe.
okay, maybe what just happened? Okay, beats me. Okay, this is arranged. It should be user defined. Maybe that had something to do with it. Connection range 100. That's fine. Okay. Oh, wait, but that was my really small population. Yeah. So no one was connected with anyone else, and they were arranged at strange places. Okay, there we go. Okay, now if I click, what do you think will happen? You think it will totally change it all around?
No.
Wait, so what connection did you just run?
100.
So this is just sticking a new person in a random place and then making all connections.
That's right. That's right. So actually here, I'll try to do it with a smaller one because it's actually easier to see what's going on. Part of what's going on visually is in response to that earlier question, I had made the size proportional to the number of connections, right? So let's go click here. Okay, here we're adding people in, and you notice some are kind of added in a. See that? It's kind of.
Why is it adding not connected?
So we currently, it's regardless which node we click, right, currently, because we don't analyze.
Correct. We're not analyzing anything about. We could ask this. We could ask information about this, and somehow use that. But here we're just adding people at random places. What's interesting is though, and I think this related to what was just being asked about now. You'll notice that it's almost like people don't appear unless they're in dyads. Like I never see a person totally disconnected appearing here. Yeah, I think the size is exactly 0. So exactly. So it's not a mystery. It's not like there's inherently a problem with AnyLogic. It's just that they have no width. Now, if we were to change that so that their width were, we're just having fun here. Yeah. If we were to change it, okay, no, we got to go down to person, and we were to change it so that their widths were, instead of being just proportional to connection number, it would be 1 plus it. Yeah. Something, or say 10 plus it, right? So to have a bare minimum or something like that, that you guarantee is visible. Then we could run it. Hey, come on. And now we have people that could be added in, and you know, as they can get added in isolation, but as soon as there's enough people around them, they get connected, and as the network becomes dense enough, they become more likely to have someone nearby, right? So.
For the sake of having a problem, how could you click on a node and make it be infected? Yeah, I mean, what
Yeah. So what you do is you unclick. I mean, the easiest way is to do this. Yeah, you message the agent itself. So you could do something like this dot, or you do send and send it to this, right? Excuse me. Is it you send an infection message, right? An infection to this. I think that's how you do it right there. And I think that will do the trick.
Could you also do it using the state
Yeah.
chart that the transition is based on a 0, 1, or a variable, and on click
Yeah.
instead of variable
Yeah,
to 1?
that's right. That's right. And in fact, you could send it directly to the state chart. You could route a message, I believe, directly to the state chart. But the most obvious way is to just send it to the person, and that's actually somewhat more general because the person probably has a way of handling messages in general. It would know how to handle that one. But yeah, that would allow you to sort of infect, disconnected nodes and so on. Right? Yeah. Okay. So enough for now. Now I'm going to try to be posting another problem set within the next few days. Also.